So let's now dive into the details. We'll try to understand what is AI, what is ML, what is data science in general at a very high level, at least to begin with, and then slowly, we'll get into the details. Let us begin by looking at a program. Now, I understand some of you might be well versed in writing programs and might quickly understand what this program is. Some of you may not have so much exposure to writing programs. So, the goal of this slide is not to assume that you know how to write programs. It is just to illustrate a bigger point that will come in the next slide. So, even if you have not written a single program before, I will try to explain what this program is. It is enough to understand what this program is trying to do, at least for our discussion, right? So, at least for this discussion, I am not going to assume that you know how to write a program. But let me explain what this program is, right? Think of this program as trying to give an yes or no answer to a question. Now, what is that question? Well, the question is, I am giving a number, an integer as input, maybe 10, maybe 20, 22, 21, whatever, right? So, some number as input, and then I have to either say false or true. It's a true or false question based on some property that this number has. Now, what is this program doing? It is checking for a certain property. And let's parse through this program and see what that property is, right? So, the first thing this program does is it checks if the number is less than or equal to 1. If the number is less than or equal to 1, the number that I give you, then you check if it is less than or equal to 1. If it is less than or equal to 1, then you say it's false. This property is false. We don't know the property yet, we'll come to the property in a minute, but whatever this property that this program is checking, it's going to say false if the number is less than or equal to 1. Well, if it is not less than or equal to 1, that is if it is 2 or above, then what it is going to do is it's going to check, it's going to take that number, let's say that number is 18, okay, it's going to start from 2 and then write down, let's say, all numbers from 2 till 18, 1 before 18, which in this case is 70. And now it's going to check if this number, it's going to go in this order, it will check if this number divides the given number, the input, right? So, input is 18. Now, you are going to write down all numbers from 2 till 18, in this case 17, and now you want to check if 2 divides 18. Well, 2 does divide 18. If 2, why? Because 18 divided by 2 is 9 and the remainder is 0, right? So, that is what this line is checking. If the remainder of dividing n by this number, which I am going to call as I, and I keeps changing over rounds, I is 0, which means that this number divides, then I am going to say false. Now, maybe in this case I am going to say false because for 18, 2 divides 18, so it is a false. For example, if I take a number like 19, now does 2 divide 19? Well, it does not, right? So, because the remainder is not 0. So, then you go to check for 3. If does 3 divide 19? Well, it does not, the remainder is 1. Does 4 divide 19? No, it does not, the remainder is 4 into 4, 16, the remainder is 3, 4 does not, and then you can keep on going till 18 because the number is 19. Does 18 divide 19? Well, it does not because the remainder is 1. So, if none of the numbers from 2 to 18 divide the given input, then I will return as true. Okay. So, this is what the program is doing, right? So, you give me a number, or let's say I give you a number, you first check if the number is less than or equal to 1. If it is, then you say false. If the number is greater than 1, then you start from 2 and go till one number less than that number and see if any of the numbers divide the given number that I gave you. If it does, then you say false, otherwise you say true. Now, pause and think, what are the numbers for which this program, this procedure will say true, right? So, some of you might have seen this already. For those who have not seen this, I want you to think about the set of numbers for which this procedure that I just described will answer true. Let us start with one example. If I give you the input as 10, will this program output true or false? Well, it has to output false because it will start from 2 and 2 divides 10. So, the answer is false. What about 23? Well, for 23, now convince yourself that if I start from 2 and go till 22 and I try to divide each of these numbers, 23 by each of these numbers, none of these numbers will divide by 23. So, this will be true. So, well, if you have thought about this, I am going to tell you the answer. It is not too hard if you think about it for a while. The set of numbers for which this program is going to say true are just the prime numbers, right? I am sure many of you would have guessed that already. So, now this is an example program, right? So, this checks if a number is prime or not. That is what this program does. It's not very important that the specific of this program, this is some program, right? So, for our purposes, think of it as some program, some procedure that takes a number as input and checks some property of this number. In this case, the property that we care about is primality. Okay. So, here is another game that let us say we want to play, right. So, in this game, I want you to guess the next number in this series, right. So, so forget the programs for the moment, this is a new game. Here I give you a sequence of numbers, let us say 2, 5, 11, 23, 47, and I ask you for the next number. What would be the next number? If you need some time, pause this video at this point and think about what the next number in this series could be. Okay. So, one way to think about this is if I give the input as 2, the next number becomes 5. If I give the input as 5, the next number becomes 11. If I give the input as 11, the output is 23. If I give the input as 23, the output is 47. If I give the input as 47, I am asking what would be the output. So, what is the relation between input and output that is common for all these numbers? And if I can find such a relationship, then I can apply that relationship to 47 and then say what the answer is. Now, again, if you need some more time, pause and think. It's not actually too hard, but I would let you pause and think to figure out this relationship. Well, I will tell you the answer now. Well, the answer is the output is 2 times the input plus 1. If the input number is n, the output is 2n plus 1. That is, if I had to write a program, then I give you a number n, the output that you would give me is 2 into n plus 1, right. So, if I give you 11, you will do 2 into 11, 22 plus 1, 23. If I give you 23, you will do 2 into 23 plus 1, 47. So, if I give you 47, then you do 2 into 47 plus 1, which is 95, right. So, the answer, the next number in this case at least is 95. Now, we have seen two different types of doing things, which is in the first case we saw a program where I gave you the program and I gave you the input and I asked you what the output is. In the second case, I gave you the input and output pairs and I asked you what program can convert the input to output. There is a very important difference between these two types of looking at things, right. So, just to clarify here, there are two different paradigms. In the first paradigm, I gave you a program and an input, and the input plus program produces an output. I gave you the number 19 and the program and I asked you whether it is going to return true or false. The input and program was given to you, you gave me the answer as true because you tried to execute the program on the input and then figured out whether it is true or false. That is one paradigm. The other paradigm is I give you the input and output. For this input, this is the output. For 2, the answer should be 5. For 5, the answer should be 11. For 23, the answer should be 47. I give you input output pairs. And now I ask you, how are the input and output related? And you figure out what is the relation by looking at these input-output pairs. In other words, your brain is creating the program that maps the input to the output automatically. The interesting question is, how did my brain do that? Right? So, in the first case, I know how the brain does it. I give you the input, I give you the program. The brain is trying to check every line of this program and see if the input matches the conditions that the program has. That's easy to replicate in a computer. The brain is also going through the program, the computer will also go through this program. We can make a computer do that. The harder perhaps and more challenging and more interesting thing is, if I give you the input and output and I ask you to figure out what is the way to convert the input to the output, your brain does some magic and the input gets converted to the output. And we really want to know what this magic is, right? So, just by looking a bunch of numbers, how did my brain know I should multiply the first number into 2, add 1 so that I get the output? Well, unless I know how my brain did it, how can I make a computer do it? So, you see the difference? Well, in one case, you have input and out program and it produces an output, which is the standard way of doing computer science. If you are a computer science student, that's what you would have done so far. Otherwise, whenever you use a computer, even if you are not a computer science student, right? So, computer is executing some program at the back, right? So, it's executing some tasks. That's the standard view. Now, we are going to take completely different view. We are going to say, I will give you the input and output. Let the computer figure out what is the program that will convert the input to the output, which is a very non-trivial way to do it, right? So, we will call the second mode of generating this program given the input and output as learning. That is, I have learned to map the input to the output. The first one is not learning, it is just executing, right? So, I have given the input and the program, you are just going through the program for the given input. That is not learning. I do not learn anything. Here, I am learning the mapping from the input to the output by just looking at some example input-output pairs. That is learning, right? And the immediate question is, why should I care, right? So, this is like making things harder for me, right? So, it is easy if you give me the program and an input, and of course, I can execute the program using the input and get an answer. But why would somebody give me input and output, and then why should I try to learn the mapping from input to output, right? So, it seems a much more harder task to do, right? So, though some of you might have immediately got it as 2 into 2 plus 1 is 5, 5 into 2 plus 1 is 11, it could have happened in a flash, but what is that flash that happened, right? So, it happened in the brain. Maybe it is easier for the human brain, but how can we make a computer do this? That is the harder question to answer, right? And the more fundamental question is, why are we even bothering about this way of looking at things, right? So, aren't standard input plus program gives output enough? Why should we care about giving input and output and asking the computer to generate a program? Why should we even care about that? Well, the reason is that's more natural, because science works that way. All of science works that way. What do I mean by this, right? So, this is so fundamental, right? So, there are 4 steps in any scientific endeavor. The first step is you observe, right? So, I am going to call it O for observe. You observe certain data. In this case, we observed that there are certain numbers 2, 5, 11, 23, 47. That was the input that was given to me, a bunch of numbers. Now, I want to find out what the next number is. In other words, I want to find out the pattern that relates the first number to the next number, second number to the third number, any number to its next number. Now, my brain has that flash that happened in my brain, if it happened, right? So, is the following: you somehow automatically hypothesized that the connection between input to output is multiplying the number by some quantity, right? So, if this was my input, this is my input, I will multiply, this is a multiplier, somehow I multiply with some number and then this is some adder. A times n, A into n plus B. Let me see if that is the relation between any two consecutive numbers. Your brain should have thought about that. You may not subconsciously, I mean, you may not consciously realize this, but subconsciously this should have happened, right? So, there is some multiplier A times n, and then some addition B, which will give me the next number. Now, the question is, well, what is A and what is B, right? So, now that is where your data comes in. I think your data comes in, and now by looking at 2, 5, 11, 23, 47, if I believe the relation is A times n plus B gives me the next number, then by looking at these numbers, well, how can I go from 2 to 5? By multiplying 2 by what and adding what? How can I go from 5 to 11? Again, there are multiple ways from going from 2 to 5, right? So, of course, you can do 2 into 2 plus 1, or you can do 2 into 3 minus 1, or you can do 2 into 4 minus 3, right? So, you can multiply it by anything and then add or subtract something to get to the next number. But we want the same A and B to work for all numbers here, and somehow our brain figured out that, well, A has to be 2 and B has to be 1, which works for all the numbers that are given in this sequence, right? So, and now I have figured out from data, which means that I have learned that, if my hypothesis that there is a multiplication factor and an addition factor that maps the first number to the second number, then I have learned that multiplication factor is 2, addition factor is 1. How we learn it, how can we make a computer learn it, we will come to that later, but I am just trying to say what might be the subconscious process that would have gone inside your head before you figured this out. And now once you learn that, well, you are in good shape. You can solve the next number for any given number, right? So, if I give you 103 as a number, well, you know that the next number is going to be 2 times 103 plus 1, which is 207, right? So, now that is like you can generalize to numbers which are outside the sequence that I have given you. Any number, I know how to, because I have the program with me, right? So, the program can take any input. In this case, 103 is the input, fine. So, 2 times 103 plus 1 will be the output. I can take any number as input. That is what is called as generalize, right? So, this is how science in general works, right? So, you collect some data, you believe or you hypothesize that this is the relation that this data essentially tries to describe. This is the aspect of the world that the data tries to describe. You hypothesize that, well, there are some numbers in this hypothesis that you do not know, in this case A and B, and now you use the data to fit these numbers. And once you have the numbers, then you can, under this hypothesis, you can generalize this to unseen data, right? So, this idea of observation, hypothesizing, learning and generalizing will keep coming back again and again. So, we will meet this again as we go along.